Good afternoon, I'm Steve Mackinson, the Chief Scientific Officer for the Scottish Pelagic Fishermen's Association, and I want to talk to you this afternoon about why scientific acoustic surveys seem to go against the grain. So on several occasions while I've been out doing acoustic surveys, I've been asked why the survey tracks tend to go in the opposite direction to the concentrations of fish and how fishermen would tend to search for fish. So this briefing hopes to shed a bit of light on that for you. So the purpose of acoustic surveys is to estimate the abundance and biomass of fish in an area by relating the amount and the strength of the echoes from the fish finder to the number and the size of the fish. So let's just take a look here. If we imagine an area, I'm going to draw this out for you. So imagine this is their area where we want to survey, and it's quite a big area. Let's say it's 300 nautical miles by 300 nautical miles, and it's an area of sort of pre-spawning aggregation, and we're trying to find how many fish in that area. Let's also suppose that there's sort of a feature, maybe a depth feature, 50 meters, heading down to some sort of deeper water. And what we need to know is how many fish in the whole area, but we can't survey every square inch of it, so there's going to be spaces between where we've looked, where we're not able to look, and we're going to have to sort of guess, make a calculated guess of what's there. So to do this, what we're going to do is use the information from the bits that we can see to estimate the bits in the areas that we can't. Right. So let's have a look at what that looks like in 3D, if you like. What it might look like underwater. Okay, so you can see that sort of depth feature there. So let's assume then that the fish, I'm going to draw in some fish marks, some echo marks over here. Various sizes, but what they tend to do is sort of sit along this edge, if you like, the 50-meter edge. But they're not only there. They are in other places as well. Perhaps not quite so densely, but they're certainly to be found in other areas. I'll just try and quickly draw those in. So there's fish all over the area, but mostly there. So fishermen know obviously where the area of high density is, and high intensity of the fish marks. So they tend to tow along that contour, and they don't waste time in areas of lower fish density. It's efficient, it's cost effective. So most of the fishing happens sort of along this area, if you like. But much to the dismay of the fishermen, when the scientific surveys, acoustic surveys come along, they're going against the grain, as it were. So what they tend to do is they come along here, down the bank, along, turn. You've probably seen these kind of things before. I'll just draw a few of these in. But you get the idea. So what they do is they go against the grain, but cutting across the contour, covering the deeper water and the shallow areas where the abundance might be lower, but as well as the edge area where there's, if you like, the hot spot area. Okay, so now comes the kind of, if you like, the scientific importance or the relevance of that, why that is. So in the scientific survey then, I'm just going to get a pointer for you, each one of these lines, the scientific lines, we call them a transect, each one of these lines represents a separate or a distinct, an individual biological sample of the average density of the fish in the area. So a snapshot, if you will, of the average number of fish in the area. And the end bits of these lines, these turning points, don't really count, aren't used. So it's going against the grain, and so each one of them, it's not one, so don't imagine it as one whole survey, it's actually a collection of a number of samples. So the direction set to ensure, so the point of that then is the direction set to ensure that the difference between the average estimate of each one of these is as small as possible. So you're hoping that the differences between them is quite small. and that makes it more reliable in estimating the abundance in the areas where we haven't seen. So you see, if let's say this one's quite similar to this one, this one's quite similar to this one, then it's likely that if you used these ones to estimate something in between, it would be quite similar. Now, if you only had one of these and had to use the basis, so you only got enough time, let's say, to cover one line and use that to guess everything in the whole area, that'd be a pretty poor basis for estimating how many fish in the whole area. It'd be pretty unreliable. So typically more lines gives you more samples, and more samples means that the estimate of the bits that you can't see gets better and better. But how many of these lines is a trade-off? How many transits is a trade-off? Because sometimes, depending on how the fish are sitting and how they're moving, it's possible that if you get them too close together, you can do double counting, count things twice, for instance. So it's not always true that more is better. It has to be a trade-off between the knowledge of the sort of fish and the distribution in the area and how much time and resource you can spend on doing that. So now let's have a look quickly at, imagine if the scientific surveys did something different. I'm just going to pick another colour here. And they didn't go against the grain, they went with the grain. So let's have a look here. So we've got, imagine they went this way instead. So you've got a line come up here, and then we move, turn, say come back along the hotspot area, down the ridge, down again. So similar, but going with the grain, if you like, and we cut out those areas. So what you see is here you've got one at the top where there's perhaps not much to be seen, one where the density, the average density of fish on this is very high, then it's quite low, and then in these perhaps it's really low. So the difference between each one of these green lines that we've got now is very high. So we call that the variance. So the variance between the samples is very high, and that makes the estimate of the average density very unreliable, and then so too the estimate of the abundance in the areas that we haven't looked. So that's the crux of it. Going against the grain provides a more reliable estimate of the average density of fish and a better estimate of the overall abundance. So what I wanted to just take a little bit of time on, sort of before we wrap up, is to go through what that, just to recap what that looks like, and also introduce another small concept. Okay, so before we wrap up then, let's consider the difference again between acoustic observations made on the scientific tracks and those made from fishing tracks. And I've got another diagram I'll put on, just so we can look at this. Okay, so if we look at the top one, that would be a typical sort of scientific survey. You can see that pattern. And if we look at the bottom one, that'd be, let's say, some typical fishing tracks. So what you can see is the spatial pattern of the fishing tracks is different from the scientific survey tracks. Rarely are they covering the whole area where the fish might be located, but they cover smaller areas repeatedly, providing a detailed and precise look within that area. And the density of fish in the areas tends to be greater. If we use the fishing vessel observations of the density in those high areas to guess the overall density in the wider area, it would bias it towards an overestimation. So it would tend to suggest that there was lots more in that area, because we're not looking where there aren't fish, or those lower density areas. But what's important here is the detail and the precise information of where those high concentrations are actually very important to know anyway for designing the scientific surveys, to make sure they're not missed. So we're not deliberately trying to miss them. We need to know where they are. So those two bits of information are important, very important to design scientific surveys. So by way of a summary then, acoustic surveys to estimate fish abundance go against the grain because it's a more reliable way to estimate the abundance and the spatial extent of all the fish in an area, not just the ones that you've seen. Scientific surveys need to cover the hotspot and the not spot areas, and industry knowledge on where and when to fish can be a big help in designing appropriate acoustic surveys. So I hope that's been informative. If you've got any questions, feel free to sort of give me a call or drop me a note, and I'll do my best to answer them. Thank you.